that didn't get it done earlier. We're solving two-step equations today. The main way of solving two-step equations, you take two steps. Okay? To undo two-step equations, you use multiple inverse operations. So like on Tuesday, we did one-step equations. You did the inverse. You added to get rid of subtraction. You subtracted to get rid of addition. Divided to get rid of multiplication, and multiplication to get rid of division. Okay. This one you have to do two of them. You will either have to add and divide, or subtract and multiply to solve the problem. You will have to do two steps. The key to solving two-step equations is not just to do two inverse operations, but you're also going to do the inverse of the order of operations. Okay, it's not just the inverse of each individual operation, you're doing the inverse of the order of operations. Okay? So I'll give people a finish writing. Hmm? It records what I'm saying. So yeah, so if you watch it, yes.
Hello. Hi.
Okay, so we talked about, I briefly mentioned, you're doing the order of operations backwards. So order of operations, PEMDAS, right? And the multiplication and division are one, and the addition and subtraction are the other. Normally, when we're simplifying an expression, what you did on the Chapter 1 test, what we've done with PEMDAS before, is you've worked in this direction. You do the parentheses, then you do the exponents, then you do the multiplication, you do the addition and subtraction. When you're solving two-step equations, you actually work in this direction. You get rid of the addition and subtraction first, and then you get rid of the multiplication and division. So you're we did one-step equations yesterday. Today you're doing two of those steps. Okay, you're going to do addition and subtraction first, and then you're going to do multiplication and division. Once again, I cannot emphasize enough how important it is to show your steps and do your work. If you do not show your work, you're not going to get credit for this. It's important to show your work. These are only two steps. We're going to get up to the next one is multiple steps, because at some point we start getting past 3 or 4 or 5 or 6 steps to solve a problem. And you have to show your work every single time, because you will get lost in a hurry if you don't. You can get lost today if you don't do the steps right. So, I have two things being done to the x here. Two things are being done to x. Okay. One of them is I'm adding 3. The other one is I am multiplying by 2. So x is being multiplied by 2, and I'm adding 3. Two things that I'm doing. So I have two things I have to undo. Normally we do multiplication before addition and subtraction, but when solving we go in the other direction. So the first thing I want to do is get rid of the addition. So I want to get rid of this plus 3. What's the opposite of adding 3?
Subtracting 3.
Ooh, good. Somebody said it. So I subtract 3 from both sides of the equation. Step number 1. My 2x doesn't change. The only thing that goes out here is the plus and minus 3 cancel each other. I still have my 2x. The equal sign comes down, and then I have 15 minus 3, which is 12. Step number 1, get rid of the addition or subtraction. Okay, so I've got rid of the addition and subtraction. I'm still doing something to the x. I'm multiplying the x times 2. What's the inverse of multiplying? What do I need to do to this?
Divide.
Divide by 2. So I divide both sides by 2. My 2's cancel here, and I get x equals 12 divided by 2
6.
is 6. Now, I want you to notice something. Bless you.
Z.
One of the things that you can do, but we are not necessarily enforcing that you do this, but this is a very good idea to do on a test in particular. Check your work. Make sure you get the right answer. It's very easy to do. Take the original problem, 2x plus 3 equals 15, and put 6 in for x. So I have 2 times 6 plus 3 equal to 15. 2 times 6 is 12 plus 3 is 15. So I got 15 equals 15. I know I did it right. Do you have to do that on the classwork? No, but you can do this to make sure you get it right. It's a very good idea to do it on your test to make sure you get the right answers on your test. Okay, next problem. Z divided by 2 minus 3 equals 5. Once again, I have two things that I'm doing to the x. I'm subtracting 3 and I'm dividing by 2. To the z, my bad. To the z. I'm dividing z by 2 and I'm subtracting 3. Which one do I get rid of first?
3 minus 3.
The minus 3, because what did I say? Order of operations, what are we doing? We're doing it in reverse order of operations, so you get rid of the addition and subtraction first. Add 3 to both sides, and I get z over 2 is equal to 8. Piece of cake, right? Yeah, how do I get rid of it? Multiply by 2. I have z divided by 2. I multiply both sides by 2. 2 times this, 2 times that. These cancel, which I really like. And then I get z equals 16. Once again, if I want to check my answer, I just say, okay, put 16 in for z. 16 divided by 2 is 8. 8 minus 3, if that's 5, I did it right. If it's not 5, I made a mistake somewhere. Go back and fix it. Questions on these two problems? These are fairly typical of most of the problems you're going to have. There's a couple other ones I want to address here in a minute. Okay. Using the equation as a model. So, you were making a bulletin board to advertise community service opportunities. You plan to use a half sheet of paper for each ad. You also need 5 sheets of paper for a title banner. You have 12 sheets of paper total. How many ads can you create? So, to set this up and do this algebraically. Now, I know many of you can probably figure out ways to do this without setting up an algebraic equation. But we want to do that to model it, but we'll talk about other possibilities as well. Okay? Levi.
Yeah.
Thank you, please. Okay. So first thing I want to do is I'm trying to figure something out. What am I trying to solve for? What am I trying to figure out? What is this problem? What am I trying to figure out? What does it ask me to find? How many ads? How many ads can I do? So I want to do how many ads. So what I want to do is I want to pick a variable that goes with that. A for ads. Makes sense. Okay. Then I look at the rest of the information that I have. Okay, I plan to use a half sheet for each ad. I have 12 sheets altogether and 5 sheets that I'm using for a title. So how many sheets of paper do I have altogether? I have 12. So that means it has to be equal to 12. Whatever I have has to equal 12. 12 total sheets equals. How many sheets of paper am I going to use anyways? 5. So I'm going to have 5 sheets that I'm using no matter what. How many sheets of paper do I use per ad? A half a sheet of paper per ad. That means I have the number of ads times 1/2 gives me how many sheets of paper. That tells me how many sheets of paper I need to do this. Or how many ads I'm going to get. Okay? 1/2 a sheet of paper per ad. So I take 1/2 times the number of ads. It tells me how many sheets of paper I need. Now you solve. Now, difference between this problem and some of the other problems you have done. And the examples that throw students off. Yeah, it's going the other way. The variable is on the other side of my equal sign. Oh my God, I have no idea how to do this. The variable's on the other side. I hear some of you cry. Sometimes with literal tears, but not very often. It's not a problem. It's not a big deal. The steps are still the same. What's the first thing I want to do? What's the first thing I want to get rid of?
The 5.
The 5. So I want to, instead of adding 5, I want to subtract 5. So I subtract 5 from both sides. And I get 12 minus 5 is 8, right? Yeah? No. It's not 8. 7. Thank you. All of a sudden I was blanking. Ooh, should have gotten a calculator. Then I wouldn't look stupid. So I have 7 equals 1/2 A. Now I'm going to write this over here just to give myself a little more room. Now I need to get rid of the 1/2 A. Okay, multiply by what? I can multiply by 2. The reciprocal. What's the reciprocal of 1 over 2? 2 over 1, which is 2. Okay. Multiply by 2 over 1, which is the same as multiplying by 2. So these cancel, and I get A, and that gives me 14. 14 equals A. So what's the answer to my question?
14 adds.
I can do 14 adds. Because that's what it asks for. Are there other ways to do this problem? Yeah. This is one of the things. Could you have figured it out anyways? Yeah. Okay, let's see. 1, 2, 3, 4, 5 sheets of paper are gone. And then cut each one of these in half. And how many half pieces of paper do I have? 14. Okay. Often in Algebra 1, the word problems are silly and you can figure them out by doing something other than setting up an equation. That's not necessarily the point. But what you did here was the same thing. You started with 12 and what did we do? We took away 5. Started with 12 and we took away 5. That's exactly the first step we did in solving the problem. And then what did we do after that? We cut every one of them in half. Half of an A. That's what we did. Which gave us double the amount. So we took them and made, instead of 1 per sheet, we give us 2, 4, 6, 8, 10, 12, 14. We did exactly the same steps, crossing it out and dividing it in half, that we did in solving the equation. The exact same steps. So you're doing the algebra, but you don't realize you're doing the algebra. Because there's not a variable written down when you're doing it this way in your head. But you are doing algebra. You just don't visually see it. Okay. Now, this next example, and I'm going to do an extra one on top of this that isn't on here to help you with some of your classwork today. Okay. This one's a little different. I have 2 things going on here again, right? I have subtracting 7 and dividing by 3. And normally, what would you get rid of first? You would normally get rid, normally you would get rid of the 7, the subtraction first. But with this type of problem, you don't. This one's different. Because order of operations, what we would normally do is you have to fix this first before you divide. So we have to do that. We need to take care of the division first. If you have a fraction and you have something on top of, completely on top of, a fraction like this, it's a little different. Instead of getting rid of the subtraction first, this is the one time you get rid of the division by multiplying both sides by 3. Put the fingerboard away or it goes in the June box and you'll never see it again. Okay. So the 3's cancel. You get x minus 7, negative 12 times 3, negative 36. This is the one time you take care of the division before you take care of the addition or subtraction. When you have everything is being divided, not just the variable. So you have to look carefully when you see these problems. And now I add 7 to both sides. I get x equals negative 29. 29. Whew. Isn't sure if it's done right. Now, I want to do another example. Yes. 36, yeah. I want to do another example to make sure you understand. Because this is one that threw a lot of people off on the worksheet that you're going to get is probably similar to this, where you have negative x plus 5. When I have the negative in front of the x, what do I have there? What's the negative in front of the x? I have a negative 1. We don't write 1 when we have 1 of a variable because we're lazy. Honestly, mathematicians, if you have x by itself, we know there's 1 of them. Why do we put a 1 in front? That's redundant. You only put a number in front when you have more than 1 of them. You don't have an apple by itself. You don't put 1 in front of the apple. You just say, how many apples? I got 1 apple, right? Same idea. So when I have a negative, it's implied that I have a negative 1 here. So when I solve this, what I do is I still get rid of the subtraction or addition. Subtract 5, and I get negative x equals 5. Now you have a choice. Either one will work. I can either multiply both sides by negative 1 or divide both sides by negative 1. It doesn't matter which one you want to do. Because all you have to do is, what you're trying to do is make that negative x a positive x. Now, the easiest thing to think of, because I have a negative 1 in front of there, divide by negative 1. The negatives cancel and I get x. And a positive divided by a negative is negative 5. When you're solving for your variables, you need to get x by itself first. Okay? Any questions? Two-step problems. What do you need to do on every single problem? Show your work. You must show your work on every single problem. No working, no stamping. Okay?
Sorry. I understand where it makes sense, but I thought a negative plus a positive is also
Multiplying.
Oh, okay.
You're multiplying.
Okay. Yeah. Well, it's making me type